Hi y'all, welcome back. So let's go ahead and solve problem 2. Problem 2. So in this problem, they want to be a little bit more numerical. They want us to plot the two-dimensionless number. Okay, so they actually give us the data. So now you guys can see the application of dimensionless group. So let me write the general method. So I write first, I would find two-dimensionless group pi 1 and pi 2. Then I will plot it accordingly to the question. Okay, so there's some unit you need to know. 1 pound force is 32.174 pound mass, IBM times feet over second square. 1 feet is actually 12 inch. Right, this will be very helpful later. Okay, what do they provide us? They provide us that the pressure change to length is a function of viscosity, density, diameters, and velocity. Okay, let's write on these in fundamental dimension. Okay, write all of these in term of fundamental dimension. Okay, so what's it gonna look like? Delta P over L in terms of fundamental dimension is M over LT squared, which is pressure over length, so it would be M over L squared T squared. Let's see the rest. Our mu is M over LT. Our rho is density, so it's mass over volume, so mass over length cube. D is diameter, is just length. U is velocity, so length over time. All right. Okay, good news for you. This problem we don't need to like test this so rigorously. We just need to go ahead and pick it. So you guys can verify later by watching. I think it's part 2. Why primary quantities, the longest video for week 10. But in this case, I'm gonna just say I'm gonna pick rho, U, and D as 3 primaries quantity. I'll make a note here. So can verify y by watching week 10 problem 1 part 2 video. Okay, so okay, we picked the primary quantity. So what's the next step? We try to answer how many dimensionless number. How many? So the number, according to the Buckingham pi theorem, the number of dimensionless group equal to the total variable, number of total variable, minus number of fundamental dimension. Right, this is according to what? This is according to the Buckingham pi theorem. Okay, how many total variables we have? Let's count with me. So we have 1, 2, 3, 4, 5. So we have 5 total variables. 5 minus fundamental dimension, we have 3 mass length time, so we have 2. Okay, let's go ahead and find those dimensionless number. Okay, let's go ahead and find them. So the first one is equal to the denominator. The numerator is anything but the primary quantities, which is rho u, not u, not d. So we pick delta p over L, and then the denominator is just going to be power multiplication of the dimensionless, the primary quantity. So rho to the power a, to mu to the power b, d to the power c. So I write in order for pi 1 to be dimensionless. You say dimension of delta p over L will be equal to dimension of rho mu to the power of a, u to the power of b, d to the power of c. Did we did something like that in the past? I think so. Let me check. Oh my god, I'm so sorry. This is not. Yeah, this is rho. So we haven't. I thought we did it because it's some familiar. Okay, so dimension delta p over L was that we already have that is this guy right here, m over L squared times t squared, which is m to the power L to the power -2, t to the power -2 equal to dimension of rho to the power a, so which is m to the power cube a, u is L b, d is just LC, right? So if you oh my god, I make a horrible mistake. Okay, I'm sorry, I have to make some correction. This is actually mu is correct. And I'm not gonna pick rho for the primary quantity, it's just mu. Okay, my apologize. This mu. Okay. So u is L, d is L, and mu, what is our mu? Mu is m over LT. M mass over length times time. Alright, if you explain all these, you get wait, what the? Oh yeah, you're right. I'm so sorry. Okay, actually, never mind. It's rho. Rho is correct. Just disregard it. So rho is correct. It's not mu. It's rho. So just sometimes I get paranoid. I don't know why. I apologize for that. Rho is correct. So this is m over L cube, and our u right here. The fundamental dimension of u is L over t. Okay, it looks nice now. Let's go ahead and proceed. So m L2 t to the power -2 equal to m a L -3a L b t -b L c. If you group them together, you get m to the power a L to -3a plus b t -b plus c. Let me make it look nice. -3a plus b plus c t to the negative b. Okay, if you equate them, you get 1 equal a, -b 3a plus b plus c equal -2. -2 equal -b. The reason why is because the power of each fundamental dimension from both sides have to be equal. Okay, if you solve the three unknown ABC, you get a equal 1, b equal 2, and c equal -1. So our first dimensionless group is delta p over L over rho u square root d. Let's go ahead and simplify it. So delta p over L times d over rho u square. So delta p times d over L times rho times u square. Okay, this is our first dimensionless group or dimensionless number. Similarly, you do the same thing for pi 2. You get pi 2, the second dimensionless number should be mu over rho times u times d. Okay, which is the inverse of the Reynolds number. Inverse of Reynolds number. Okay, so after you did all of this, now you are ready to plug in a number and plot. Okay, so the data they provide you with the data for on the variables. Now you can find the dimensionless group. Okay, just don't forget, make a note, don't forget to convert pound force to pound mass times feet per second square. Okay, so let me give you the number so you can put into Excel and see what you got. So pi 1, pi 2. Okay, so for firstly, pi 1 should be 0.0195236. Pi 2 should be 0.000223. Next one, pi 1 should be 0.0175144. Pi 2 should be 0.000134. Pi 1 should be 0.01558783. And pi 2 should be 8.97 times 10 to the power negative 5. Last but not least, your pi 1 should be 0.0013268868. And your pi 2 should be 4.47 times 10 to the power negative 5. Okay, you plot this out and you get a plot of maybe pi 2, pi 1, something like this, and you can get pi 2 is a function of pi 1. Okay, this is one example of dimensionless group analysis. So instead of, you have to draw a lot of graph, right? You have to, if you want to study the relationship between these variables, instead of, you do a row visit D plot, row visit U dot plot, D visit U plot, mu visit row dot plot, so many combinations, right? But in this case, you just need to study the two-dimensionless group, and it should give you sufficient data how to relate them. Okay. Okay, so I hope this is helpful for y'all, and stay tuned for the next video, and I wish you guys an amazing day.